tap dancing to keep us entertained.
No, we'll do it. We're going to go here.
And Bart is using AI to do the design. Isn't that wonderful? Look at that.
So tonight we're going to deal, I mean, you get this impression that all of these prophets and so forth were all there thousands of years ago. Well, this is a prophet, oops, who was born in the United States, as you'll see, and had a huge impact in the first uh, part of the century, the 20th century in the United States, and yet no one's heard of him anymore. But he definitely is a mystic, and uh, it's interesting to try and couple up with him to see what in the world we forgot. So here we go. So Walter Russell, this is a picture of him here. Um, was born in Boston in 1871. He left school at age 9 and went to work and then put himself through the Massachusetts Normal Art School. And he interrupted his 4th year to spend 3 months in Paris at the Académie Julian. And his biographer identifies 4 instructors who prepared him for a career in art: Albert Munsell and Ernest Major in Boston, Howard Pyle in Philadelphia, and Jean-Paul Laurent in Paris. So in his youth, Russell earned money as a church organist and music teacher and conducted a trio in a hotel. And he left Boston in 1894, so he was 23 then, I guess. And uh, he married his wife, who died in 1953, and they traveled to Paris for their wedding trip. And he had a second term in the Académie Julian. And after the wedding, they settled in New York City in 1894, had 2 daughters, and Russell's rise in New York was immediate. A reporter wrote in 1908, Mr. Russell came here from Boston and at once became a great artistic success. So he became a painter, just with all of this great training. And we'll see some more of this. So at age 29, he attracted a lot of attention with his allegorical painting, The Might of Ages. The painting represented the United States at the Turin exhibition and won several awards. And he also decided to publish children's books. So he wrote 3 of them by 1903 and qualified for the Authors Club in New York City, which he joined in 1902. In 1916, he founded the New York City Skating Club. There's a pond in Central Park that freezes over, so people go skating on it. He made his mark as a builder when he created $30 million worth of cooperative apartments. And in particular, the one that's very well known is the Hotel des Artistes, which is on West 67th Street, just directly west of Central Park. And the people that live in it, it's the Hotel des Artistes, are artists. So the artists go ahead and did all kinds of paintings, which are hung all over the hotel. But in particular, on the first floor of the Hotel des Artistes is the Café des Artistes. And the Café des Artistes has loaded with paintings of all the residents that were there. So this was something incredibly successful. People loved it. And he was also involved in a variety of other development projects. In the 1930s, though, check this out. He was employed by Thomas J. Watson, who was the chairman of IBM, as a motivational speaker for IBM employees. He was employed by IBM for 12 years. That's actually where I ran into him, as we'll see in a second. So let me just do some background on this IBM thing. Thomas Watson Sr. became the president and CEO of a company called Computing, Tabulating, Recording Company, and he thought the name was absolutely terrible. And he wanted to have some really spiffy name, so he renamed it International Business Machines,
Oh, that's
or
so much better.
IBM, in 1924, even though there was hardly anything international about it. But it was the market leader in punched card tabulating systems for businesses. So people would have these card punches. So IBM made money selling them the cards. Then they would have these card punches. There'd be a keyboard, and you'd punch and make holes in the cards. And this was entering all the data. And then there was these electromechanical sorting machines that would sort the data on whatever fields you wanted to go sort it on. And this became actually the basis for business, for doing accounting, anything you could think of for business in the United States, going right up to the advent of going into electronic computers. So Watson had a sales background, and what was unusual about this is that he's the president of the company, and salespeople usually get paid on a percentage of whatever they sold. So he asked to be paid as a percentage of the gross annual revenues of IBM. And in the 1930s, Watson was the single highest paid corporate officer in the United States. Every year he got his percentage of the IBM gross revenues. So with that as a background, we see a picture here of a magazine called Think, the first principle of business success. And it is uh, the magazine was given to IBM customers, and IBM had all these signs everywhere that said "Think." So Russell was the one who motivated them to think, to think outside the box. If you got a problem, don't just do it the same old way. Ask yourself how many other ways there are to solve it, and what can you do, and so forth. So these were all collected in a book, and the book is what I read. I worked one summer of '67, for IBM in Poughkeepsie, New York, and that's another story. So IBM founder and president Watson and Walter Russell lectured for 12 years to IBM executives and employees, and they pioneered a visionary new concept of ethical business practice, exploring the use of unchanging universal principles of balanced thinking and action that are as valid today as they were in the 1930s. Now, this is interesting that this is said here, because what I didn't say was that Thomas Watson, prior to joining IBM, was the head of sales for National Cash Register. National Cash Register made cash registers, and they were a formidable market force in the cash register market. And Watson, being in charge of sales, decided to improve sales. So he started manufacturing knockoff machines of his competitors' products. And then he hired people to say that they were salespeople from this other XYZ company, whatever it is. And they were going to sell them a cash register at a much lower price than they would get from NCR, National Cash Register, which is all true. What they didn't say was the cash registers that they were building were very error prone and would fall apart very quickly, and they would take forever to service them. So the customer of the competing product would get fed up, and they say, "I'm just going to go with National Cash Register. They're the best that there is." Okay, this was discovered, and Watson was fired in a big rush at National Cash Register. So here you see him putting this spin on it. This is typical Watson of ethical business practices. Okay. So, but as near as I can tell, IBM, I'm only aware of one instance of an unethical business practice, and even this is questionable. In the 1960s, middle 1960s, IBM announced a line of what they call 360 computers. So they spanned a range of performance of about a factor of 50 from the smallest to the largest. And this was all on paper, okay? That was so they started building these things and they discovered they could build all of the low-end ones. When they tried to do the very high-end 360 Model 90, they couldn't do it. The performance they're trying to get, they couldn't reach. And the end result of this was, though, that since IBM had announced this 360 Model 90, its competition, which is Control Data Corporation, sued IBM for announcing a non-existent product. IBM never did get it to work. And when I was there in the summer of '67, they had they had a totally separate group at IBM called Product Test. And so this group would take whatever product IBM had announced and they would get the manuals and they would plug it in and they would see, does it really do everything that it was supposed to do? Well, the 360 Model 90 never did what they claimed it could do. And with the summer of '67 was the third time that they ran it through product test and it flunked. And then IBM was forced to give up a significant business, a $1 billion a year business called Service Bureau at that time, to Control Data in recognition of having done this. So with that as a background, Walter Russell speaks to the IBM management in today's language. It's very readable. There's all this stuff that the possibility that work can be an expression of one's genius and a path of self-fulfillment. He speaks about the unifying power of the global business industry for the creation of universal peace and prosperity on Earth. While a learning organization requires a culture and system of continual development of outer knowledge and skills, which Russell calls resources, a character-building organization requires, in addition, a culture and a system of continual development of inner self-knowledge and genius, which he calls resourcefulness. So the organization's character is its destiny. The character of an organization is the integral of the character of all of its employees. So IBM was able to shape this culture. It was amazing how they started off in the U.S. and then they went international. And what the international side of IBM was called IBM World Trade, and they just kept this common culture of the company wherever they went. It was an incredible achievement because they got up to hundreds of thousands of employees doing this. They changed incredibly as a company. So this is a visionary new concept called ethical business practice, unchanging universal principles of balanced thinking. And Russell speaks in today's language about the possibility that work can be an expression of one's genius and a path of self-fulfillment. And there's a unifying power of the global business industry for the creation of universal peace and prosperity on Earth. So, interesting. While a learning organization requires all these things, the character of the organization came out in this magazine, Think, that was there in every IBM office. You could see a copy of Think magazine, and you would always see a placard, little wooden block that said Think on it. And it might say IBM and Think also. So when he was 56, Russell turned to sculpture. He'd never sculptured before, but he did portrait busts of Thomas Edison, Mark Twain. The Mark Twain bust is in the Mark Twain Museum in Hannibal, Missouri. General MacArthur, John Philip Sousa, Charles Goodyear, George Gershwin, and many others. And he won all kinds of commissions for doing this. And Franklin Roosevelt had him do the Four Freedoms Monument which is there in Washington, D.C. in 1943. So, from having no experience whatsoever in sculpture, he becomes, the top sculptor in the U.S. I have no idea how he did this. And he became a leader in the science of man movement. He was elected president of the Society of Arts and Sciences in 1927, and he wrote over a 7-year period many, many articles for the New York Times, and the gold medals awarded by the Society were highly valued. As World War II approached, he moved into the top floor studio at Carnegie Hall, where he lived alone. His estranged wife lived in Connecticut. Everybody ends up living in Connecticut. At the time, he was supervising the casting of the Four Freedoms, and this was a low time that required a rejuvenation of his health and spirits. And there were reports of his egotism and self-aggrandizement that really bothered him. He wasn't shy. So here's where the mysticism comes in. I just walked around it. Russell claimed to have experienced a transformational or revelatory event. Actually, he had his first one of these when he was 7 years old. But here we are in 1921. He's now 50 years old. So he later described this in a chapter of a book he wrote. It says that during this period, this is a 39-day period where he has these visions. I could perceive all motion and was newly aware of all things. Russell used the terminology of Richard Maurice Buch in the book that he wrote, Cosmic Consciousness, to explain cosmic illumination. Later he wrote, "It will be remembered that no one who has ever had the experience of illumination has been able to explain it. I deem it my duty to the world to tell of it." And this became the subject of another book he wrote, The Divine Iliad, and he published many other books. Here's just an example, by the way. I was talking about him as a sculptor. Here's this bust of Mark Twain that's in Hannibal, Missouri at the museum there. And here are some of the books. These are not all of the books that Russell wrote. So, on top of everything. So, he's very, very well known. And yet, if you asked anyone, who is he, you wouldn't find out anything. So let's go back again to his 1921 event. This is what he looked like, by the way, this is 1904, this picture. So he's a painter here. And in 1904, he would have been 33. So there's just a series of books he wrote on this experience, on what he saw in this 39-day period. And we're going to look at those now. But he wrote at the end that religion and science must come together in a new age. He never referred to an anthropomorphic God, a human-like God, but rather wrote, "God is the invisible, motionless, sexless, undivided, and unconditioned white magnetic light of mind, which centers all things. God is provable by laboratory methods," he wrote, "and the locatable, motionless light, which man calls magnetism, is the light which God is." So that's what he says. Okay. Let's see. This period was, again, heightened awareness and understanding. He felt a fundamental connection to the universe and its principles. But you'll see how successful we are at trying to understand what he saw. But it did influence everything. So, for example, after this is when he met Watson, and when he was writing all this stuff for the New York Times, and dealing with IBM managers and so forth. So he definitely didn't have a screw loose to be able to attract all these people. So I've got 3 videos here. and we'll just run through them, and you'll get some idea of what in the world this he saw in his mystic experience. So hold on a second while I go to find the right one. Oops. This isn't going to do it. Hold on a second. Okay, here's the first one. These are all short, so we'll see how we go. Okay, can you see this, Bruce?
Yep.
Okay, here we go.
Welcome back to the channel. Today we'll explore the visionary world of Walter Russell, the man who dared to challenge conventional scientific thinking. The great Serbian inventor, Nikola Tesla, was a big fan of Walter Russell. He was so impressed by Russell's ideas about the universe and how it works that he advised Russell to keep his discoveries hidden away for 1,000 years. Tesla believed that humanity wasn't ready to fully grasp and appreciate his profound insights just yet. From scientific philosopher to renowned sculptor, painter, author, musician, and mystic. And if you enjoy figure skating, he introduced figure skating to America. While many of Russell's ideas have not found widespread acceptance among mainstream scientists, his unyielding commitment to forging connections between science and spirituality has left its indelible mark. In his book, The Secret of Light, he writes,
"Man lives in a bewilderingly complex world of effect, of which he knows not the cause. Because of its seemingly infinite multiplicity and complexity, he fails to envision the simple underlying principle of balance in all things. He, therefore, complexes truth until its many angles, sides, and facets have lost balance with each other, and with him. Truth is simple. Balance is simple. The rhythmic balanced interchange between all pairs of opposite expressions in natural phenomena and human relations is the consummate art of God's universe of light. It is also the law."
Russell believed that all matter is created by dividing gravity into pairs, and created a mesmerizing chart that unveiled the intricate dance of every element along a 9-octave cycle. To illustrate his hypotheses, Russell relied on illustrations that are as visually striking as they are mysterious. Born to Nova Scotian immigrants in Boston on May 19, 1871, Russell led an unconventional life. He had his first illumination experience at the age of 7 in 1878. It will be his first out-of-body experience. In 1885, at 14 years old, he was reportedly pronounced dead after an attack of black diphtheria, but claimed he was asked to return during another out-of-body experience. He claimed at some point to have been struck by lightning. The year 1921 would be life-changing for Walter. He started his self-study.
Do you want to know where to invest $1,000 right now? Well, forget about AI, quantum computing.
And was the first to coin the phrase electromagnetic wave universe. As he turned 50 in May of 1921, his life took an unexpected turn with another out-of-body experience he termed cosmic illumination, during which he received new knowledge in the light. This great intellectual and spiritual encounter provided him with profound insights into the nature of matter, light, and the mechanics of the universe. Immersed in this amazing cosmic state for 39 days, Russell utilized the opportunity to document and illustrate everything he discovered, intending to share his newly discovered knowledge with the world. Through his newfound insight, Russell unveiled a remarkable discovery. All matter originates from a zero-point field of energy, the genuine essence of the universe. He revealed that
We are all electric creatures floating in an electric sea of this electric universe. The electric energy which motivates us is not within our bodies at all. It is a part of the universal supply which flows through us from the universal source with an intensity set by our desires and our will.
Perhaps the most significant consequence of his illumination was the Russell periodic chart of elements that he introduced in 1926. His periodic table not only offered a clear and sophisticated explanation of the composition of atoms and various elements, but also successfully predicted the discovery of radioactive elements, which had not yet been discovered at the time, such as deuterium, tritium, neptunium, and plutonium. What is most remarkable about Russell's periodic table is the completely unconventional approach he takes to explain the ultimate framework of nature and its elements, which, according to him, is wholly musical in its structure. According to Russell, nature is divided into a total of 9 distinct octaves or pressure states. These 9 bands are employed to categorize elements based on varying forces of compression and expansion. He wrote, "It will be remembered that no one who has ever had the experience of illumination has been able to explain it. I deem it my duty to the world to tell of it." Walter believed he could now perceive all motion and was aware of all things. The New York newspapers of the day published articles stating that Walter Russell challenged the Newtonian theory of gravitation.
It would be more fitting for an artist of Mr. Russell's acknowledged distinction in his field to remain in it. For nearly 300 years, no one, not even a scientist, has had the temerity to question Newton's laws of gravitation. Such an act on the part of a scientist would be akin to blasphemy. And for an artist to question Newton is crass ignorance.
Russell pivoted to sculpture, achieving worldwide recognition with remarkable creations like the Mark Twain Memorial and the Four Freedoms Monument, which was commissioned by President Franklin Roosevelt, creating larger-than-life busts of American heroes like Thomas Edison and George Gershwin. He even held the prestigious title of official sculptor at the White House. What makes this accomplishment particularly astonishing is that Walter was a self-taught sculptor. And from the very beginning, he produced stunning sculptures. There was no learning curve. He started as a master. Russell deeply believed that every human being is capable of extraordinary things and can achieve greatness by respecting and recognizing man's cosmic connection with the universe. He said,
I believe that every man can multiply his own ability by almost constant wordless realization of his unity with his source. I have myself made that feeling so much a part of me that I actually feel myself to be an extension of the source, that my works are not my own, but interpretations of this source.
Walter's artistic ability allowed him to depict his three-dimensional universe in a two-dimensional graphic format. He went on to craft numerous enigmatic and artistic graphics on space, time, motion, and the cosmos. These remain a mystery even today. Driven by an obsession with the physics of light, he pioneered New World thought, authoring over a dozen books on the subject. Notable works include A New Concept of the Universe, which came out in 1953, in which he developed a different understanding of light, matter, energy, electricity, and magnetism. Walter Russell believed that all matter emanated from light, emphasizing interconnectedness, relativity, pairing, and balance in everything. His theory supporting diagrams are artworks in their own right. Intricate intersecting hoops, vibrant, pulsating radiation illustrations, and twisting pyramids and polygons. They bear a striking resemblance to the abstract geometric art of his time, like the modernist works of Kandinsky. Aside from his pursuits in science and art, Russell had a leisurely passion for figure skating. He established the New York Skating Club, organized an event at Madison Square Garden, and brought in top instructors to popularize figure skating in America. Remarkably, he continued winning competitions into his late 60s. In 1948, Russell received a mysterious phone call. When Daisy Stebbing read Walter Russell's book, based on his belief that the foundation of the universe is love, balance, and unity, she called him.
I know your voice. I've been hearing it inside of me for decades.
Walter Russell dubbed her Lao after the Chinese philosopher Lao Tzu, the author of the Tao Te Ching and the founder of Taoism. He divorced his first wife of 50 years, and 2 years later, at the age of 77, he married 44-year-old Daisy, an English immigrant, former model, and businesswoman. It was quite the scandal. The newlyweds traveled the U.S. seeking a home for the Walter Russell Foundation. They found a neglected Italian Renaissance villa in Waynesboro, Virginia, and transformed it into the University of Science and Philosophy, a foundation and museum for Walter's work. There, the couple continued publishing books. They were particularly concerned with the radiation legacy from the nuclear fuels, which they warned against in their book, Atomic Suicide, which came out in 1957. In 1960, Walter and Lao Russell published The Electrifying Power of Man-Woman Balance. The Russells wrote this book to usher in a new era in human affairs, one that aligns with the unwavering laws of nature. Walter Russell passed away in 1963 on his birthday, May 19th. He was 92 years old. Upon his death, Walter Cronkite of CBS News called him the Leonardo da Vinci of our time. Despite his extensive writings and insights on scientific topics, Walter Russell is often dismissed as an outsider, a pseudoscientist, with his ideology rarely accepted by the mainstream scientific community today. He believed he could see the very essence of creation and that every man has consummate genius within themselves.
Mediocrity is self-inflicted and genius is self-bestowed.
If you found this video informative, be sure to like and subscribe for more explorations into history, spirituality, and the mysteries that continue to captivate our curiosity. Until next time, keep exploring, and may your journey be filled with enlightenment and divine guidance.
Okay, so there you have the first video.
You were familiar with him before.
I was, yeah, in 1967 when I was at Poughkeepsie, I read some of these articles in Think, and they got collected into a book called Think, and so forth. But he was very well known. Okay, now there are a lot of people. Hold on, let me get out of this. There are a lot of people that he after his stint in 1921, he wrote up a bunch of things on this and sent it off to hundreds of people. The only person that replied to him was Nikola Tesla. And Tesla said, "This is wonderful. You should put this, I'll make a time capsule for you, and we'll have it go for 1,000 years. And 1,000 years from now, we'll open it up and everyone will realize how right you were." That's what Tesla said. So, you know, what can you say? So now let's go here to the next one. You'll get some idea. This guy, you know, is his own man. He was, again, very, very well known. Oh, wait, I forgot to check one thing. Yep, we got sound on, okay.
Have you ever pondered the correlation between the universe and human consciousness?
Hold on.
And
You see this, Bruce?
Yep.
Okay.
Today, we're soaring deep into the universe of thought enlightened by Walter Russell, a man many consider the Leonardo da Vinci of the 20th century. His theories about the universe and its connection to the human consciousness are profound. Let's start with Russell's fascinating concept, the universe as a realm of balanced stillness. To him, the cosmos is not chaotic or arbitrary. Quite the opposite, it's a meticulously balanced system, where every action reacts equally. This idea of balance is not just confined to celestial bodies, but extends to all known and unknown phenomena. Russell once said, "The universe is a living, breathing, thinking body." Now you might ask, what has human consciousness got to do with the universe's balanced stillness, this living, breathing, thinking body? Well, according to Russell, everything. He believed that the universe responds to consciousness, implying that our thoughts, actions, and intentions profoundly impact our world. Russell's ideas were a radical departure from the conventional scientific views of his time. He argued that science's cardinal error was shutting the creator out of creation. In essence, he suggested that we cannot fully understand the universe without acknowledging the creative force behind it. One of Russell's seminal works is A New Concept of the Universe. In this book, he delves into these ideas, painting a picture of a universe that is far more interconnected and responsive than we might have ever imagined. He suggests that our awareness can alter the motion of life, an irresistible proposition that challenges us to think about our role in the grand scheme of things. In the eyes of Walter Russell, the universe is in motion, patterned, and responds to consciousness. Walter Russell, a man of many talents, is often called the Leonardo da Vinci of the 20th century. A polymath in every sense of the word, Russell was proficient in various fields, including painting, sculpture, architecture, and science. His genius was not limited to a single sphere but flowed freely, crossing boundaries and breaking down walls. As a young man, Russell demonstrated an innate talent for painting and sculpture, creating works that were both technically proficient and artistically evocative. His early works in the arts not only gained him acclaim, but also laid the groundwork for his later foray into the world of science. His artistic eye and keen understanding of form and structure were instrumental in shaping his unique perspective on the universe's workings. His entry into the realm of architecture was equally impressive. His designs were innovative and forward-thinking, reflecting his belief in the power of creativity and the human mind's potential. His architectural endeavors were not merely about constructing buildings, but designing spaces that could inspire, uplift, and nurture the human spirit. But it was in the field of science that Russell's genius truly shone. His theories and ideas, though initially met with skepticism, have since been recognized for profound insight and revolutionary approach. Russell believed that the universe was not a chaotic, random place, but a beautifully ordered system governed by laws of balance and harmony. His work in this area laid the foundation for his later theories on the nature of light and the interconnectedness of all things. He once said, "Every action in nature is voided as it occurs, is recorded as it is voided, and repeated as it is recorded." This quote beautifully encapsulates Russell's belief system, emphasizing the delicate balance and order inherent in nature. As a man of varied talents, Russell's work spanned a broad range, all leading to his profound understanding of the universe. Imagine a universe of balanced stillness, where the creator divides the balanced ether into imbalance. A thought-provoking concept, isn't it? This is precisely the universe as viewed by Walter Russell. He postulated a cosmos where balance and stillness are the norm, a silent symphony where every note the creator strikes results in a ripple of imbalance. As Russell once said, "The universe is founded upon love, for God is love." This imbalance, according to Russell, sets in motion a series of actions and reactions. Imagine tossing a pebble into a serene pond. The moment the pebble breaks the surface, it disrupts the tranquility, creating ripples that spread outwards. This is akin to the creator introducing imbalance into the universe, disrupting the otherwise balanced ether that propels the cosmic dance of galaxies, stars, and planets. Now, let's delve into one of the most intriguing aspects of Russell's universe: gravity. In our everyday understanding, we view gravity as an invisible force pulling us down to the earth. Russell, however, had a different take. He envisioned gravity as a condensation and compression of waves. Think of it as the universe's way of squeezing together the waves of imbalance caused by the introduction of matter. In essence, gravity is the universe striving to restore balance by pulling together the ripples of imbalance. It's an eternal war between the creator's disruption and the universe's relentless pursuit of equilibrium. This cosmic interplay between balance and imbalance, stillness and motion, is the heart Russell's universe. In this fascinating cosmos, the tranquility of a pond is disturbed not by a single pebble, but by countless pebbles, each creating its ripple, its wave of imbalance. These waves collide and intersect, forming the intricate dance of universe. So in Russell's universe, imbalance and motion are intertwined. The cosmic dance continues with each ripple, each wave, each galaxy and star playing its part in this grand symphony of balanced stillness. This is the universe, according to Walter Russell. A universe where every action, every reaction, every wave of imbalance is a testament to the grand design of the Creator. Can the universe truly respond to our consciousness? Question might sound outlandish at first, but not when you delve into the works of Walter Russell. Russell, a man of profound knowledge and insight, believed that the universe is not a chaotic mess of random occurrences. Instead, he proposed that it's patterned and, more intriguingly, it responds to consciousness. Russell's perspective is a stark contrast to the prevalent scientific focus. Today's science leans heavily towards understanding the universe through the lens of force, pushing, explosions, decay, chaos, and destruction. It's almost as if we're convinced that the universe is a battlefield where elements clash and collapse, giving birth to stars and galaxies. Russell invites us to look beyond this battlefield. He suggests that the universe is more than a colossal tug-of-war between forces. It's a living entity that responds and interacts with our consciousness. To quote Russell, the universe is a cosmic cinema, the play of light and shadow. It's a bold claim, one that pushes the boundaries of our understanding, but then again, isn't that the very essence of science? If we pause and consider his proposition, it presents a fascinating possibility. Imagine a universe that doesn't merely exist, but one that responds, that changes in response to our thoughts and consciousness. It's a concept that bridges the gap between the physical and the metaphysical, the seen and the unseen, the known and the unknown. But how does this response manifest? Russell believed it's not in the grand, explosive gestures we're accustomed to associating with the universe. It's not in the fiery birth of a star or the explosive death of a galaxy. Instead, it's in the subtle, almost imperceptible pull. It's in the silent, gentle tug that nudges the universe towards a state of balance and harmony. Russell's view, the universe's unseen creative part is a matrix of pulling, not pushing. It's a perspective that invites us to reconsider our understanding of the universe and our place within it. It's an invitation to explore the universe not as a battleground, but as a dance floor, where every step we take, every thought we have, could lead to a cosmic waltz of unimaginable beauty. Light, a common yet mysterious part of our universe, but what is its secret, according to Walter Russell? In Walter Russell's enlightening work, The Secret of Light, he unfolds a captivating perspective on light, presenting it as the basis of all existence, the fundamental foundation of the universe. This isn't merely about photons or wavelengths. This is about light as a profound living substance, a dynamic force that breathes life into every corner of the cosmos. Russell's perspective is unique and transformative. He perceived light not just as a physical phenomenon, but as the living substance of the mind. As he himself put it, light is the living substance of mind in action. It's a bold thought, isn't it? To imagine light as the active expression of universal consciousness, the tangible manifestation of the mind's creative power. This is not about seeing light as we traditionally do, but about understanding it in a new, deeper context. Russell challenges us to rethink our relationship with light, to see it as more than just a source of illumination, but as a radiant symbol of life itself. So when we look at a beam of sunlight or the twinkling stars in the night sky, we are not just seeing light. According to Russell, we are witnessing the active expression of a universal mind, the substance of existence itself. This light is the creative force that gives birth to the universe, a continuous act of creation that unfolds before our eyes. Imagine then a universe woven from threads of light, each beam a testament to the mind's creative power. Every sunrise and sunset, every star and galaxy, all manifestations of this radiant force, this secret of light. Russell's theories remind us that every aspect of our universe, from the smallest particle to the grandest galaxy, is connected through this living tapestry of light. This perspective, while unconventional, offers a profound and poetic view of our universe, inviting us to look beyond what we see, to question, and to wonder. In Russell's theories, light is the cornerstone of existence. Walter Russell took his ideas further, proposing a universe of one. As he famously quoted, "We are all one with the universe." In this vision, Russell doesn't see the universe as a collection of separate entities, but as a unified whole. It's a concept that nudges us to look beyond ourselves, and realize that we are all part of an interconnected cosmos. In his work, Russell paints a picture of the universe not as a cold space, but as a single entity pulsating with life. A universe where every star, every planet, every is intrinsically connected to the other. He believed that understanding this oneness, this interconnectedness, is the key genuinely comprehending the universe. Imagine for a moment a single thread. Alone, it may seem insignificant, but when woven with countless others, it forms a beautiful tapestry. The universe of one, as proposed by Russell, is akin to that tapestry. Each of us, each atom, each star is a thread contributing to the grand design. Russell's universe of one is a fresh perspective, a shift from the conventional understanding of the universe. It's a vision that encourages us to see beyond the physical, beyond the tangible, and into the realm of the interconnected. It's a vision that emphasizes the harmony and balance of the universe and our role within it. In a universe of one, there's no you or me. There's no here, there. There's only us and everywhere. It's a concept that transcends physical boundaries and unites us all under the same cosmic roof. It's a concept that fosters unity and discourages division. In the grand scheme proposed by Russell, we are all part of one interconnected universe. Walter Russell's works provide a unique perspective on the universe and our place within it. His vision of a universe in motion, constantly changing and evolving in response to the consciousness of all beings within it, challenges our ordinary perceptions. He saw not a universe of chaos and destruction, but balanced stillness, where every action has an equal and opposite reaction. This universe is alive, aware, and constantly interacting with us. Russell's concept of light, as revealed in The Secret of Light, is not merely a physical phenomenon. It is a fundamental aspect of existence, a force that drives the universe's ceaseless motion and connects everything within it. For Russell, light is the essence of consciousness, the medium through which we interact with the universe and contribute to its endless dance. In his universe of one, Russell presents a vision of unity and interconnection. We are not isolated beings adrift in a vast cosmos. We are integral parts of the universe, each unique expression of the same fundamental consciousness that pervades all things. We are, in essence, the universe experiencing itself. Russell's ideas have profound implications. They invite us to see ourselves not as passive observers of a distant and indifferent universe, but as active participants in a cosmic dance of creation and evolution. They challenge us to recognize the power of our thoughts and emotions to shape our reality and our relationship with the universe. As Walter Russell said, in the grand scheme, we are not separate from the universe, we are the universe. As we conclude our journey through Walter Russell's universe, remember that in his view, we are all interconnected parts of a grand, moving cosmos. His works encourage us to embrace this truth, to recognize our place within the universe, and to live in harmony with its rhythms and cycles. Ultimately, we are not mere spectators, but dancers in the great cosmic ballet, partners in the universe's ongoing dance of creation and evolution. And in this dance, each of us has a vital role. As we move, so does the universe. As we change, so does the cosmos. And as we grow, so grows the universe. For in the end, we are not separate from the universe, we are the universe. And the universe is us. We hope you found this exploration of Walter Russell's universe enlightening. If these concepts resonated with you or if they sparked your curiosity, we encourage you to delve deeper. Russell's works, The Secret of Light and Universe of One, are fascinating reads that will broaden your perspective. They offer profound insights into the universe, consciousness, and the interconnectedness of all things. By diving into these books, you'll continue the journey we've only just begun here, expanding understanding of the world uniquely. And remember, knowledge is not just for keeping, it's for sharing. So if you have friends or family who would appreciate this enlightening exploration, share this video with them. As Walter Russell once said, keep exploring the universe within and around you. This quote brilliantly encapsulates our message today and is a mantra we hope you carry forward. Thank you for joining us on this cosmic journey. Remember to like, subscribe, share, and stay curious. Until next, keep honoring Russell's words by exploring the universe within and around you.
I have to finish writing this paper. I'm swamped.
Okay, so there you have the second one. It's getting a little deeper. The third one, the one I saved for the end, you'll see is borders on incomprehensible, but hold on a second. Yeah, here we go.
Oh, he's speeding it up. I was gonna say it was.
What's an hour? Hour of video. So let's go here. And if it's too much, we'll just cut it off. Get the hook out. Okay, do you see this, Bruce?
Yeah.
Okay, we'll crank this up. Got the captions on. Okay, this guy back here, this is the person introducing him, is from that Walter Russell Science Foundation in what is it, Virginia. So here we go.
Your program. But I wanted to mention a couple of things, what it does not say. So first of all, let me mention the first sentence. Scott has studied theoretical physics as a hobby. Who does that? When I had the chance to intersect with Scott was when we were working on the Russell experience before. And I've been so impressed with his enthusiasm, with his commitment. And I remember Darren telling me about how he kind of knew that Scott was the person that was supposed to follow him, because he had so many notes in all of his science books that he knew he was really into it. Please join me in giving a warm welcome to Scott Vanderpool.
Today, I'm going to be talking about Walter Russell's concept. My name is Scott Vanderpool. I'm the Chief Science Officer of the University of Science and Philosophy. I've got about an hour, so this is going to be a brief introduction. We're going to talk about light, motion, and forces, okay? Now, I want to talk about concept versus a theory. A lot of times with science, you hear, Einstein's theory of general relativity. Theories are things that there's been experiments done by multiple people. They've been, compared to nature, of observations of nature, and they turn out correct. So if you get enough of that, you can have a theory. But what starts before the theory is the concept, okay? So Newton had a concept that mass attracts mass, and it went on to become a theory. Einstein had a concept that space-time is curved. That went on to become the general theory of relativity. Russell also had a concept. That's what we're going to talk about today, the idea, a new concept of the universe. So all like science concepts, you have to start somewhere, right? So a postulate or an axiom, a postulate or an assumption, it's a statement that, it's not proven yet, but it's just a starting point, okay? So we have to start somewhere. And I'm going to start with 3 of Russell's postulates. So, and people at home now the people who are here, you guys are already interested or already have experience with Russell, but there might be people watching this later that, this is brand new. So I say to those people, have an open mind, and we'll start with the postulates. These 3, you have to have an open mind and say, okay, I'm going to believe that these are true. Let's just pretend these are true. Then we can have a conversation, okay? So postulate 1 is that the universe is made up of only one substance, and that's light. Number 2, the universe exists in only 2 states, stillness and motion. Now I got motion in bold because that's really what we're going to talk about mostly here. And then there are only 2 forces, gravitation and radiation. And I remind you guys, keep an open mind, because we know in standard physics, there's 4 forces. But what if there were only 2? Gravitation and radiation. That's what Walter's concept says. So we're going to talk about that. These are some of the research books. Now, later, this video will be, people will be able to watch this later, so you can pause it and you can kind of get this information. But these are, I've read all of these. These are great. If you're interested in the science, I highly advise you to read these books and the home study course. That's even more in depth than the books, okay? The next few slides are free to pause later. I'm not going to go through all this, but this is like the puzzle pieces of Walter's concept that I think are needed for you to understand if you're going to learn it. Don't worry, don't try to read them all. You can pause this later. Okay. Now, they're also, he brings some new concepts. Once again, you can pause this later. I just wanted to get these on here for people to see later, because I just don't have enough time to go through all of this. All right. And here's some of the benefits of Russell's concepts, the real world benefits. I'll go over these briefly. One of the benefits of his concept is that it's one set of laws for all matter on all scales. It is a theory of everything. We don't have that in physics yet. It explains things like the double slit experiment, because matter follows gravitation. Well, I'm going to stop there. I need to teach you some stuff first before we go into that. But also there's less experimentation in chemistry. We're going to know how all of the elements work together. And these ones in blue are kind of my own personal opinions. I think that we will be able to precisely calculate where particles are. Like there won't be a need for quantum mechanics probabilities and uncertainties. Like we'll know exactly where things are if we use Russell's concept. And also I think it'll explain gravity in a way that the motion of the stars and galaxies will be explained. There's not gonna be a need for dark matter or dark energy. So these are big ideas, okay? All right, so let's go back. We're gonna start on these postulates. So light, everything made of light. I like to say, you know, Russell kind of describes it. Okay, so for the people who haven't really learned about his philosophy, there are plenty of books. I'm only gonna do his philosophy a little bit here, but so Walter had a 39-day illumination where he got this knowledge and then he was able to put it down into books, okay? And he kind of, the way I like to say it is there's kind of two universes. I'm putting in quotes. There's not really two universes, there's only one. But for understanding of his philosophy, one universe is like the universe that we sense with our five senses. You know, this table, everything, okay? That's the sensed universe. The other universe, we can't sense it with our senses, but we can, he says we can know that it's there. I like to think like the little voice that's like inside your head, like we all have it. You don't actually hear that like with your senses, but you know it's there, okay? That's just like one example. So these two universes, we're gonna talk about stillness and motion. Light, so remember everything's made of light and it's either in stillness or it's in motion, right? So we're gonna talk about light and stillness. It can't be seen with our human senses. It's like, you know, when you look out into space, you can see the stars. The darkness that's in between, you can't see it, but you can perceive that it's there. I'm gonna give you an example. So think of an indoor swimming pool. It's been like closed for weeks. The water surface is motionless and it's smooth like glass. Now to describe these properties of stillness, I'm actually gonna describe something that's more familiar, which is motion for you guys. So like imagine we throw a little pebble into that still pool. What happens? Motion starts, little ripples, little waves, right? And these waves, you can measure a wave. You know, it has dimensions. Length, width, height, right? You can measure the frequency at which the crests rise and fall. You know, you can measure the time it takes for a crest to move a distance, which gives you speed. I put move in quotes because in Walter's theory, light actually doesn't travel. It's an illusion. Well, I'll get into that later. Now, say you throw a big bowling ball into that pool. These waves are gonna be different, right? They're gonna be, you know, the amplitude's gonna be higher. These waves are gonna have different dimensions than the little ripples from the pebble, right? So all of these different measurable wave properties are dimensions of the wave. They're dimensions of motion. And that's a really important concept in Walter's concept is motion, light in motion, okay? So in Walter's concept, there are 18 dimensions of motion. All right, more on that a little bit later. But I first have to clarify, these dimensions, they're not outside of our three-dimensional space. Like someone saying, oh, I've been teleported, you know, to another dimension, like, you know, a parallel universe, like, you know, the multiverse kind of theory. It's not that. These dimensions are also not like abstracted, you know, mathematical dimensions. It's not that either. We're talking about dimensions in the real world that we can measure. These are properties of nature. So I think that's one of the strongest parts of Walter's concept is that it can be directly measured in nature. And so we can observe things and check it to see if it's right. So here are the 18 dimensions of motion. I mean, I'm gonna go through these just briefly. We're all kind of familiar maybe with the first three, like distance, then you got area. You know, if you have two, now you got area. You add, you know, height, now you got volume. We've got time, which is just duration. We've got sex, which in my view is kind of like plus and minus polarity. I think Matt Pressey's gonna do a talk on that later. Pressure, potential, that's kind of a new one. I underline potential because we're gonna go into that a little more in depth in this talk. Then there's things like temperature, ionization, crystallization, valence, which has to do with chemistry. Number 12 and 13 are interesting because they are both dealing with time. Axial rotation, which is like, you know, you've got the Earth, it's got a North Pole and a South Pole, and it's spinning on its axis, right? He calls that speed time. And then you have imagining the Earth orbiting around the sun, that's called power time, that orbital revolution. All right, next is mass, and then color. You know, we're kind of familiar with these. Number 16 is plane of gyroscopic rotation. This is another, I haven't seen this anywhere else in science, but like, so if you imagine a spinning top that you kind of you spin it, and then it can stand up straight, like 90 degrees. Like when it stops, it's just down. But when it's spinning fast, it's up 90 degrees. As it starts to slow down, you know, it starts to wobble, right? And so it will, and the slower it goes, the farther down it goes until it stops. So this angle from 90 degrees, you know, down, these are the angles of plane. He calls that plane. It's the gyroscopic rotation. And so that's an important dimension of motion to measure. Number 17 is the ecliptic. And that's kind of, if you imagine the Earth, North Pole, South Pole, you've got the equator around the middle. The ecliptic is really like the equatorial area. And he talks about that expanding or contracting. That is another significant thing to measure in terms of a dimension of motion. And the last one is tone or sound. So that's all of, and all of those are measurable. And what's interesting is that all of these dimensions are linked together. If one of these changes in any little way, then all the other 17 also change. Okay, so it's really fascinating, and it gives us some insights. All right, so light and stillness. So now we can describe light and stillness compared to motion. So stillness is the opposite of motion. Therefore it has no dimensions of motion. There's no time. There's no beginning or end. There's no distance, because no one point is discernible from any other point. Like, everything is infinitely the same. And I admit it's hard to fathom when you first kind of hear this. But this is part of Walter's philosophy. Remember I said those two universes? So the light and stillness is like this one universe that's just, it has no beginning, no end, no time, no distance. Every one point is the same as every other point. So like whether you're here or way thousands of miles, millions of miles over there, it's the same point. So that's just a unique thing to his philosophy that you guys can learn about. There are 2 points where he said we could perceive the light and stillness. So say you have 2 planets, planet P and planet Q. Right in the middle of the planet is a point of stillness. And then also between these 2 masses, there'll be a point of stillness. Let's see if I can do a little, see my pointer. Oh yeah, here we go. Yeah, so right here in between, there'll be a point of stillness. So as many of you probably already know, light in motion, it can be seen by our human senses. But it's important to understand that we can only see a portion of this moving light. And just because we can't see the light doesn't mean it's not here. Like we've seen that, maybe you've seen this. This is like a spectrum of light, where you go from like, we'll notice that like the human senses can only see this little sliver, this little white band here, okay? But just because we can't see this other moving light, like ultraviolet, it's still there. It's just too high frequency for us to see. It's like a dog whistle. It's still there, but we just can't hear it, right? So it's important to just acknowledge that. So now we're going to discuss how light moves. And we'll talk about, this applies to both the moving light that we can see and the moving light that we can't see because it's out of our range. Not to be confused with the still light that we can't see, okay? So we're gonna have to discuss the forces that make light move. One of the major differences in Walter's concept versus traditional science is that, so if everything is made of light, remember that postulate, then that means light has mass. And that's a separation from traditional science. If they talk about particles of light or photons that don't have mass, and that's in another section, like where we're looking at the standard model of physics versus Russell's, and that's only in a more in-depth version of this presentation. We can't do that right now. So we're going to talk about the forces, gravitation and radiation. So there's first one important thing that I'm hoping to get across to you. If you learn this will be kind of a gateway into his science, and it's equilibrium versus polarization. So we're going to do a diagram here. Now we got two tanks of air, okay, and they are connected with a little pipe. The air can flow freely through this pipe, okay? So that means, this is at equilibrium. These are at equilibrium. And we got some little pumping device here in the middle, okay? So actually, let me go back here just to reiterate. This is a universe of equilibrium and balance versus a universe of polarization, or more and less. Those are those two universes I kind of talked about. So you imagine 2 tanks of air connected with a pipe, and the tanks start at equilibrium. Now, when the pump is turned on, it's going to pump air, and I'll show you another. It's going to pump air from one side in this direction of this arrow. So now there's more on this side where we put the plus, and there's less on this side where we have the minus, okay? Right, so it pumps most of the air out of one tank into the other tank, okay? So now we have an imbalance. This is what we call polarization. So more air is now compressed into a smaller volume. In one tank, the air is now under higher pressure and is denser than it was before. And the air in the other tank is now at a lower pressure and is less dense. Okay, so we call this imbalance polarization. So let me see if does that make sense to you guys? Are you following me here? That's what a polarization is. Okay, maybe. Okay, wait, is there anyone who doesn't get that yet? Raise your hand. Okay, so imagine, all right, so you get the equilibrium state where there's just air in a room, like it's all kind of at the same pressure, right? If I turn on that pump, it's going to start making the air go this way. So now there's going to be way more air on this side than on this side. And that's all I'm saying, is that's the polarization, that there's more in one area and less in one area. Make sense? Okay, okay. So yes, I mean, you could say this whole system is polarized. It's actually both tanks, the whole system is polarized because there's more in one area and less in another area. That's polarized. But what you're talking about in terms of this tank with the plus, Walter would say this tank is charged. It's been charged up, okay? I'll talk about that a little bit more later. All right, so now we're gonna talk about gravitation and radiation. So look at these. So in a simple nutshell, gravitation, you got like a sun right here or a planet, this circle, and all these arrows are pointing to the middle. Gravitation it's the inward direction toward the center of mass, okay? Versus radiation, if you think of the sun like light coming out of the sun, that's everything going out away from the middle, into space, if you will. Okay, that's kind of the general idea of the two forces, and these are the only two forces in nature. That's what Walter is saying. I always try to start like kind of simple, and then I'll just like reiterate it and make it a little more complex. So now let's talk about the description of gravitation. Gravitation is the force that causes light to move toward the center of mass. I'm going to show you there's something for you to keep in mind here. Planet P, we got planet P over here, planet Q over here. All right. So now when I read this, you can kind of keep this picture in your mind. Gravitation is the force that causes light to move toward the center of mass. Russell calls this direction north. He says north is positive. So the center of mass is the most north point and the most positive point. So Russell calls gravitation a positive force. So that's why we have the plus sign right in the middle there. Now radiation is the opposite of that. It's the force that causes light to move away from the center of mass. Russell calls this direction south. South is negative. So the plane that's between the two centers of mass, here I'll show you that. It's like this plane here that's between the two suns or planets is the most negative southern point or south point. So he calls that that radiation is a negative force because of that. All right, let's move forward here. And just so you know, these two forces are always opposite. Gravitation and radiation. If gravitation is going this way, then radiation is going to go this way. Okay, it's like a rubber band. If I stretch a rubber band like this, as soon as I start stretching, like if that's gravitation, pushing this way, well, radiation wants to push it back immediately. If I stretch it far, you got like a lot of gravitation. Well, then you immediately also have a lot of radiation trying to push back. Like as soon as I let go, it's going to slap back. Right. So it's an action and reaction. So they're always there together, in opposition. So all light moves in a curve. Specifically, it follows the path of a curved spiral, and it always has a specific cycle. I'm not going to talk about the cycle right now. We don't have time. We're going to say that light starts as a base of a cone. Now, I need to give you an example here. You guys, like in a bathtub, when the water goes down the drain, there's that spiral. Okay, it's a vortex. And it's in a cone shape, like it starts wide and it gets smaller and smaller, till it goes down the drain. So that's what we're looking at here, on the bottom here is like a spiral going down the drain, right? And it's the same thing on the upside, is that spiral. So when I say, and it gives a cone shape, see this cone shape. So when I say light starts as a base of a cone, it's starting on this two-dimensional plane that's right in the middle here, this 2D plane. All right, so now you kind of have that graphic in your mind. I can read this. So light starts as the base of a cone, and it extends spiraling outwardly, away from the 2D plane, out this way up and out this way down. It's a 3D spiral vortex, and it's the force of gravity causing this cone-shaped vortex, and it compresses light into a smaller space. As light is compacted into a smaller volume, it becomes more dense and under more pressure. This plane, you're going to see this throughout my presentation, this kind of peach-colored two-dimensional plane here. Just remember that guy, okay? So that guy is the plane of equilibrium, or it's the southern inertial plane. Now at the top of the vortex, that's north up here. And at the top of this vortex, well, I guess it's going down. That's also north. Normally we think on a map like north is up and south is down, but in this case, south is in the middle and north is at the ends of the cone. Okay? Here's directly from the Universal One. Walter says, all direction is curved, all motion is spiral. This would be like you looking down the drain as the water spirals down the drain. Okay? And gravitation is what's taking it down the drain, but radiation in 180 degrees, it wants to go the opposite direction. All right, so now we're going to talk about three-dimensional polarization. Whew. All right, so here we go. You remember this, guys. This was our equilibrium box, right? With our more and less, that polarization that we learned about. And remember this guy. Now we're going to start to put it together. So now I'm going to do three boxes. Same thing. We're starting at equilibrium. These pipes are open. The air can flow freely through here. It's all at the same pressure, okay? But when we turn the pumps on this time, one pump is going to pump this way, and the other pump is going to pump the other way. Now we've got less in the middle and more on the outsides, okay? So what we're going to do is remember this guy, this double cone thing. We're going to put him on here, turning him to the side, and show you that this is how the pumping action works. So gravity is like a pump. It's going to compress things towards the cone apice, the points of the cone, here and over here. And in the middle, there's going to be less, okay? More on the outsides, less in the middle. So it's the same thing here. Now we've got our two planets. So we're going to start to see how this concept of gravity is working in our universe, our solar system. Like these are actual planets here, okay? So we put the cones here. This is gravity. This is what happens. Gravity pushes towards the center of a planet. The cone, that spiral vortex compresses things towards the center of the planet. Same thing over here, towards the center of the planet. And in the middle, there's less stuff. And that's why there's darkness in between the planets, Okay, there's still light there, but it's just so spread out, it's beyond our senses. Okay. So sometimes one spiral vortex cone meets another spiral vortex cone, and when the two vortices meet, light can become concentrated in such a small volume, it becomes dense enough that our senses can start to see it, where we couldn't see it before. Here's kind of a picture from the universal one of like two of these things meeting. Now light gets to a maximum point of compression and density and pressure, you know, that like in the center of the sun, it's got to radiate somehow. It's got to come back out. And it radiates in a spiral and becomes less compressed and less dense. It's the force of radiation that causes it to spread out like a flat pancake shaped spiral. You think like the Milky Way galaxy shape. So I'm going to show you here. So this, I love this diagram. To me, this is the shape of gravity. You've got in the middle, you can see a cone on the top here, and then you can see a cone on the bottom. They're meeting in the middle, okay? They're bringing light, winding it up into this center mass. But then it's got to go somewhere. So what happens is it shoots out the sides, you know, as rings, you know, and it ends up going back to where it started from. Here, I'll superimpose. Remember this, our little friend, the two-dimensional plane. There's one up here as a base of a cone, and one down here as a base of a cone. And I apologize for this next graphic, but it was the best I could do, but I hope you get the idea. So we're going to see the spiral in there. Can you guys see that? I've got the, you know, the spiral one coming down and the spiral one coming up. It's kind of hard to put that in there, but I hope you guys can see that. Now how does this look in space? Walter drew it for us. We see spiral like the Milky Way. This is if you're kind of looking down on it, I guess. But here he drew it if you're looking at it on the side. And look, he drew the spiral cone. You know, one is here. See, here's our little two-dimensional plane guy, the base of the cone. It spirals the light up, it winds the light up and brings it here. And then this one over here, winding the light up, bringing it here. It brings it all to the middle. And then what happens? It's got to go somewhere. So it goes shooting out the sides. All right, and that's how you get like the shape. And it ends up going out the sides. And then what does it do? It goes back to where it came from where it started. So light ends up back where it started its cycle to then repeat again. So how does this kind of happen? We got to talk about three-dimensional vortex motion now. We see our same guy here, but Walter adds something called the cube. All right. So now I love this graphic that he did. He shows, see these two arrows here? You can imagine one is gravitation, say coming down. Then you got radiation, which wants to go 180 degrees against it. Well, it's like they're playing a game of chicken. They can't run into each other. So what happens is they turn right at the last minute before they crash, right? And so what happens if we put a cube here, if this happens in a cube, this is what happens. They have to turn. So it starts this spiral motion. And it just so happens that it follows kind of the path of least resistance in this cube, you know, and it goes towards the corners. So when you have two vortices meeting, it really kind of more looks like this. So you got one over here winding up and meeting this other one over here winding up. And you'll notice that he has these numbers 1, 2, 3, 4, 4, 3, 2, 1. These lines, this is what I talked about with the dimension of gyroscopic plane. You know, when I said you have the top spinning and it'll either fall down. So he shows us that these planes, they're important in his concept. They have to deal with chemistry. These are just locking positions. It just so happens that like things lock in that position. He has something called the formula of the lock potentials. Let's see. Now let's see what it looks like in more of a three-dimensional thing. Now we've got a cube here with a spiral. It's spiraling up towards the corner of the cube. We've got an adjacent cube over here where it's spiraling up towards the corner of the cube. They meet here. So this is where all the mass would be. This is where like a sun would be, okay? And once again, he draws these planes, you know, the 1, 2, 3, 4, 4, 3, 2, 1. That's just something that's significant. I don't have time to go into that, but it's something that's significant in his when it comes to chemistry. All right, it's worth mentioning that Walter Russell had to choose terminology, you know, to describe his concept. Sometimes he used words that already had meanings in science, and he changed the meanings of those words for his concept. So it can be confusing. I just wanted you guys to know that, like, if you go to start reading some of his books, you know, and I'll try to clarify. Like, for example, the term magnetism, he uses this term to describe the radiation force, okay? And then the term electricity, he uses that to describe the gravitation force. So he likes to set up, you know, electricity versus magnetism. I just think because that's what was going on back when he was around. But so I like to use gravitation and radiation instead of saying electricity and magnetism. It's just a little more confusing. Same thing with magnetic. He talks about magnetic versus electric. He'll say that magnetic, he uses that term to describe the unmoving still light versus the moving light he calls electric or electricity. Okay, so that's once again where he's putting this electric and magnetic just because they're kind of opposites. But so just to try to clarify that for you guys. And one last thing, which I thought also was confusing, was the way he used the term charge. Okay, I'm going to show you, remember this when we learned about this polarization. So this box here would be charged, okay? And he puts a plus there, so some people would think, okay, it's positive charge. but it's not. So over here, you've got a minus, but this is not negative charge because you can only charge that by putting more. Now you can discharge this and it would go back to equilibrium, but the way that Walter uses charge, he just says, it's like describing more or less of something going from 0 to maximum charge and then back to 0. It can never be a negative charge like that. He says that would be like saying silent sound. Okay, well, let's see. That's the end of the presentation for now. How much time do we have, Kim? We have till.
So you still have some time and we can field questions.
How much time do we have?
You always want more.
I mean, because I do have one. I have one or two more concepts that are a little more advanced. That's kind of was the basic stuff. So
let's pause for a moment.
Yes.
Let me breathe in for a minute.
Let's pause.
Breathe in, and I'm sure there are some questions here within the audience.
Do you see any way that the different forms of your magnetism could describe anti-gravity?
Yes, actually, that is the next thing that I was about to discuss would describe that actually.
Okay. All right. Well, you're setting up. Did he pay you for lunch?
That was great. That's perfect.
Okay, in terms of temporal or time-based,
yeah,
the two vortices, the gravitational and the radiative, occur simultaneously?
Yes, and so I didn't describe that very well, almost just to try to be easy on people. But yeah, actually, gravitation and radiation, they happen simultaneously. Like I said, the example of the rubber band, as soon as you start an action, the reaction is like wanting to happen, immediately. Like they go hand in hand. So yeah.
Other questions? Yes, Margaret.
Would the charging motion be male and the discharging be female?
Yes.
Bingo, you win.
Bingo.
Ding, ding. Pass it on back. You can pass
There's someone in the back
pass
there.
It behind you. Go all the way to the back row. Just pass it on back there, please.
When you said light doesn't travel, and you were going to come back to that, and maybe you did, but will you say what you meant?
Yes,
okay.
I think that is in the next more advanced section. So
okay.
yes.
So Scott,
yes.
Is it the case then that light travels from the corner of each of the cubes to the next cube?
No. Yes and no.
Is that the mechanism by which?
So okay, I'll describe it. Actually, I mean, I have diagrams for this in the next section. Like this is exactly what I'm about to explain.
All right, you got 13 minutes.
Okay, let's go.
He did pay me, so.
All right, so for this one, we're starting right here in 3D. A cubic wave field. You got one cube here. You got another cube here. So I'm gonna let you look at this. Ooh. Okay, so on this side we have imagine gravitation because you can see like these rings are going in towards the center, right? We can all see that. And on this side, the rings are going outward, away from the center. This is like radiation, okay? And now what happens when we put these two together? This is what happens when you overlay them together. Now, if you notice, you can kind of look in the center, and you see it's alternating between like a white circle and a black circle, okay? Now, what I'm gonna do is have you realize that when you're seeing this is just a two-dimensional version. But remember, we wanna do this in 3 dimensions. So what I'm gonna have you imagine is that if you imagine a cube and the center of a cube, now, instead of seeing this in 2 dimensions, just like as rings, if you could imagine this as a sphere, okay, so that you have these, like the sphere all around, like is going towards the center, okay? If you can imagine that side as a sphere going towards the center, and imagine this side as a sphere, but going out radiatively, like out in all directions, okay? And so then now when we get to this, we have to imagine this as in 3 dimensions as a sphere. So it's pumping. Okay, it's a spherical heartbeat, if you will, and if you can imagine this sphere like in a cube, right? We're still looking at like one cube here and another cube here, but in each cube we have this going on. We have this 3-dimensional pumping. It doesn't leave the cube; it's just pumping in its cube. Okay, so to address the light not moving. Yeah. Sorry, that's Okay, yeah. I think we got the point. right. Okay.
Oh.
Right. We are. Okay, so the example that I like to use in terms of light traveling is if you guys have ever seen like at a big sporting event, there are people in a big stadium and they're all in their seats and they can do something that's called the wave. So it's like if everyone just stands up and then sits down like at the right time, then there's an illusion that there's a wave traveling around the stadium, okay? That is the illusion of light traveling. It's analogous to that, because you have to think, each person is only in their seat, and they're just pulsing like a heartbeat up and down, okay? When we have our 3-dimensional, as we go back to that, remember this guy pulsing in a 3-dimensional sphere? It stays in its wave field, and it's just pulsing in its wave field. But there's one wave field here, and there's another wave field here pulsing. And then there's another wave field and another wave field. Okay, they're all like adjacent. So if they pulse just right, there'll be an illusion that light is traveling, okay? So in Walter's concept, light doesn't actually travel, but it's an illusion of motion that we see with our senses that it looks like it travels. Question? Wait, let's get you on the microphone. Yeah.
If I stand up and sit down, then she signaled for her to stand up and sit down.
Yes.
So there's some sort of information, I'll call it, going from one to the other.
Yes.
But literally, I'm not moving this way and that way. I'm only going up and down.
That's right. That's right.
So just like it did, will it start in one cube and then that somehow signal to the next cube and to the next
Yes.
cube and the next cube?
Yes.
Is
And
that how it
so
works?
that's a great question. Perfect question. So yes, when an action starts in one cube, so say we're in this cube, when an action starts in this cube, and now this is just something unique to Walter's science. And it's, to me, like one of the most incredible things. And for me, like the hardest thing to believe. But like he says that if something starts here, it immediately affects everything in the universe. Like he says, you can move your little pinky and you're affecting a galaxy billions of miles away. Okay? So, and it's clearly faster than light travel. Okay? To me, it blew my mind. But so yes, when something happens in one place, it happens everywhere. And that's kind of the universe of the still light. Something happens in one place, it happens everywhere. So the whole universe is connected as one. Wait, we had a question over here and then one over there.
So this is what's referred to as the universal heartbeat then?
Exactly. That, or, you know, that other hypnotizing looking thing. Yes, that's the universal heartbeat.
Action and reaction is simultaneous.
Yes, because gravity is like the action and radiation is the reaction. They're actually simultaneously, and they're happening simultaneously, you know, in that heartbeat.
So therefore, light does not, as you were alluding to, light does not travel. Its presence is everywhere all at the same time.
Yes, you got it. Yes, it doesn't have to travel because it's already everywhere. And that's why, like in Einstein's theory of relativity, he said light moves the same for every observer, no matter like how fast you're going. When I was first learning that, I was like, how can that be true? If I'm going this fast and I shine a light, you know, I'm going faster than that guy. But if light is already everywhere and it's only just pulsating, yeah, no matter what speed you're going, it's gonna be the same for everyone. Okay, I want to hold off on questions there because I want to try to finish this more advanced. Okay, we're gonna look at gravity, Newton's gravity versus Russell's gravity. Now we remember the whole equilibrium more and less with the tanks. We remember this, that we had like an imbalance between the tanks. So now we're gonna look at equilibrium and polarization in terms of things like a battery. Some of this, okay, let's see. I already went over that. Some of this is going to be a little just kind of intuitive. I don't have time to explain the exact function of this, but I think with the diagrams, I'm hoping you'll kind of see, just intuitively get it. So if you have a battery that have, you know, a plus charge on one side and less charge on the other, it's polarized. This is kind of what the symmetry would be like with this AB static equator. Now, if we change that to like an unequal volume, where we make this really small, but we make the other side of the battery really big, you're going to get this equator that's more curved, and the symmetry is going to look more like this. Now, I hope you guys can get that intuitively or by the picture, because it's really hard to explain. I don't have time to explain it. But the point of this is that now if we look at a bar magnet, okay, we've got our little two-dimensional plane here. You know, a magnet is just a piece of metal, and it doesn't become a magnet until it's magnetized. They take a piece of metal, they wrap a coil of wire around it, they run current through the wire, and then that magnetizes the metal. So what it does, it pumps potential to one side and to the other side. Now we've got that, it gets polarized essentially. So that's why, you know, you can pick up something on the end of a magnet on either side, but not in the middle. Now Walter takes it one step further and he goes, okay, imagine this magnet. Now we're going to fan it out and it's going to look like this. It's the same magnet, but just he made this end wide and this end small. He said you could pick up a nail over here, but over here things are wider. You couldn't pick up a nail, but if you ground the nail up into powder, you could pick up the equivalent's worth of powder of a nail on this side. But there's a difference in potential. Like over here, there's a lot more. Over here, there's a lot less. Now, if we imagine that same fanned out magnet, like two coming together like this, remember there's more here in the middle and less on the outside. It's this polarization. This is like the planet Earth is right here. There's more stuff in the planet, but then outside around the outside, there's space. There's less stuff. And what that means is that everything has a potential position. This is a direct quote from Russell. He says, every potential has a balancing potential position somewhere in the universe. What he's saying there is like, if I have a thing, it wants to go where its surrounding is the same potential as it. Here, I have something to show you. Here's an example. All of these things are different things. They all have their own kind of density, their own potential. And they, like in the middle there's I think, what is it? A cherry tomato, it says. And you can see the cherry tomato is floating right in the dish soap, apparently. It wants to go, their potential is the same, or their density, if you will, is the same, okay? Whereas a ping pong ball, it's mostly air, so it's gonna wanna be up here. So he says, everything has its balancing point, and it desires to find that position. And desire to find that position in every creating thing, and any restraint exerted against, like to prevent it from moving to finding its balancing potential, can be measured as weight. Like that's what weight is. It's just something, when something wants to go somewhere and you don't let it, then it'll exert a force, and that's what we call weight. So the interesting thing about this, so his theory works on all scales. So this right here is kind of a smaller scale, but if we look at this, this is what happens. This is the larger scale. The planets are the same as, this over here. You've got the sun down here, which is the highest potential in the whole solar system. And as things get farther out away, they get less and less potential. Less dense, exactly, less dense. And that's why the inner 4 planets here, from Mercury, Venus, Earth, and Mars, they're rocky. They're solid. You get farther out, now all the planets are gaseous because they're less dense, they've expanded. So Walter's concept of gravity, this is what I'm hoping that you get, that it's actually the way that gravity winds up light into more dense things, and radiation unwinds it into less dense things. That's what we call, he called it potential. So I must have missed a slide, but I'll just explain it. So like potential, an example of potential is like a gas. A gas is very low potential. Then next would be like water or like a liquid. That's higher potential. And then you've got a solid, like a rock. That's the higher potential. Okay, so things will try to find their balancing point. And that's really, in Walter's concept, that is what is causing gravity. Everything that you see around us is because of its potential. It wants to find its potential position. And that's what really is controlling everything. So, so let's see. Oh, yes. Okay, so, I wish I had a graphic for that. So you're referring to, so Walter talks about a constant, that there's like an energy constant, and how to describe this? So everything has to be balanced. So if you, for example, have, I guess, an elephant on one side of the scale, you could have a little ant on the other side of the scale, but there would have to be, thousands of ants or whatever, a million ants in order for it to be balanced. I guess like, I guess the closest thing I have to that would be, this is probably the closest thing I have to that. Okay, so over here, this would be kind of like the elephant. It would be very compact, very dense. So extremely dense. Yeah, exactly. So it could affect a solid object like the nail. Out here, it's extremely tenuous. So it's basically like the bunch of little ants, okay, versus the big elephant. But if you imagine like a seesaw, these two, they balance each other out. It just takes, many more ants versus like one elephant. That's not the greatest explanation there, but I hope that makes sense. There's a great, are we running on time? There's a great, in the universal one, there's a great graphic for that. But anyway, I think my time is up. So we have a question. Yeah, so please, I would like to say, please come talk to me if you have questions. I would love to talk with you about all this stuff, and and I can answer questions and talk to you about this. So, bye.
Okay, so there you have an attempt at trying to get across what he's doing. Now, I think there's actually a lot of truth in what he's got there. When I think back to what Ron Cowan observed, okay, he saw this blocks of information that were coating every compartment of space, and they would be scanning all around, and they would detect changes, and when they detected the changes, they would store this, and they had algorithms that allowed them to actually control the forces. So this essence that was all around is linked to everything everywhere, and probably it's running at some instantaneous speed, simply because how do you really coordinate all these things? If you have any time delays, you'll end up with all kinds of problems. So it could be that what Ron observed with the scanning of these information everywhere, that was part of it. Another side to it is these notions of What? And that could also be true. So I'm just picking up on these things to show you that that's what's going on. But you can see how hard it is to capture what, he spent 39 days in some sort of coma and trying to write this stuff down. And it just wasn't enough time for him to actually figure out how could he explain this in some way that people could really understand it. So, but I still think that there's more to be done here. And we're going to compound that by next week having an interview with a guy named David Chalmers, who, why don't you grab the gizmo over there? He was a grad student in Cambridge and Oxford in theoretical physics, and he had these visitations with extraterrestrials, is all I would say. And so he ended up dropping out of conventional mainstream physics and went off into this much more esoteric activity. What we're going to be talking about, he has, in this interview, which you'll see, he describes this gizmo here. Let's see. You can see this blurring thing doesn't work. I'm going to turn the blurring off so you can see it. Okay, so it's wood. This thing is pyramid here, 2 pyramids here, and some dowels, okay? This thing actually has an element of consciousness in it, in here, I think. And it exhibits this incredible warmth that just kind of goes around everywhere. So we're going to talk about what this guy saw, and you can buy these things, okay? If you want one, okay?
Which Bart did.
Yeah, which we did. So that'll be the subject of next week's class. These mystics are everywhere, okay? They're not just thousands of years ago. They're very current, and we'll see where all this leads. So with that, anything you want to say, Bruce?
No. After all that, wow, yeah, right.
Yeah. Well, you can see why Walter Russell had trouble. Well, most people just dismissed what he was saying.
I liked where it was talking about the degree of potentiality and
Yeah.
the increase in that in the actuality.
Yeah, I thought that was a good idea. It's it needs a better exposition, but I think there's really something there.
That's very Kabbalistic.
Yeah.
Where the tree is showing the degree of actuality from the totality of infinite potential. Where am I? Coming down into existence is a process of subtraction or division rather than addition and multiplication, which is what we think of creation being. But if you're starting with the mystical perspective of the oneness, you're extracting from that oneness into the illusion of particularity, knowing that it's an illusion. But that's the whole game that we're playing here. We're talking about a particular chair, not just the essence of chairness. You want to know, is it a rocking chair? Is it a swivel chair? Is it, more than one style at a time? It could be. Some are mutually exclusive and some aren't. But in order to be a particular chair, it can't have every quality of chairness. Some reduction has to take place.
Rocking chair. Yeah.
Right. And I've just kind of I felt that intuitively as this guy was, particularly this presenter was talking about it.
Yeah.
And to me that's really interesting as a mystical perspective on the science of it.
Yeah, I'll try and capture this next week when we have this other guy, David Chalmers, talking, and I'll try and get in what Walter Russell was saying and contrast it with David Chalmers. So that'll be the homework assignment we have. So anyway, thank you,
All right.
thank you for coming, and
All righty.
another week.
All righty.
Have a good. Bye-bye.
Bye.
Good night.